problem that we had at Groundshaw, and I'll take you through how we managed to solve it using Apache Sedona and how it's managed to help us. So on the right-hand side is one of the data sets that we have within Groundshaw, and what you're seeing on the map is hex grids covering the entirety of the UK. So there's about 61 million of them, and the colours there, each one has an associated risk score for each one of those hexagons. And that's based on the aggregation of about 60 plus different data layers, aggregating it down all into like a single risk score between about 1 and 15. So each hexagon's about 2,500 meters squared. And just the hex grid alone, without the rest of the data, makes up about 56 gigabytes of data. So you can imagine it's getting pretty big already. And then plus with our layers, all the layers that are going into this, that's adding another almost about 100 gigabytes on top. So it's becoming a very big geospatial data set, and it's a lot of data to work with. So initially, when we first looked into doing this, we looked at a few different methods of how we could actually process this data. First one, we looked into FME. We use FME for a lot of our geospatial processing as it is, but we just found it was taking too long to read all of the data. And actually, it became a big bottleneck for all of our resources. We've only got a certain number of licenses, and we're trying to do all of our other geospatial processing, and we just couldn't have that time taken out. We also looked at GeoPandas, but again, it wasn't necessarily that fast at reading all the data, and we quickly ran into memory issues with the amount of data we're trying to read. So our final sort of thing was just using SQL, and just using SQL store procedures. We know quite a bit about SQL, and we're able to write some sort of quite complex stuff in there. But just the sheer size of the data was causing problems within our databases, causing locks on some of the tables, and actually stop us doing from some of our normal functions. So the actual initial solution we went down was using SQL and a lot of store procedures. But the way we kind of tried to overcome this issue was we broke down that hexagon grid into about 100 different sections, and we just took each section at a time and ran them each at the same time. But this actually kind of led to us having multiple store procedures. We'd have one store procedure for each layer, and then we'd have to actually run each one of those store procedures several times for each section of the UK. And kind of all in all, to run this entire thing and get the output data set was taking us about 10 days, which is really quite slow. A lot of the layers that we put into this are being updated. Some of them updated daily, some of them updated monthly, weekly, yearly. So you can imagine this model is going to need constantly updating to keep it up to date. So this just wasn't sensible. This just wasn't a viable solution going forward in the long run. So this is where we kind of started looking around at other solutions. We actually migrated our databases from MS SQL Server to Postgres, and that provided us an idea of, well, is still doing it in store procedures the best way to go, or is there a new way of doing it? So this is where we start looking at Apache Spark. So for those of you that do know Apache Spark, then maybe you can help with a little bit of this. But Apache Spark is a data processing engine for big data, and it allows you to process data across a single node or multiple clusters. So that kind of top diagram over there helps explain. So you have effectively a manager computer that then passes your code down to some worker computers, and they can each store some of the data on there, and then they can process the data. So it works on this kind of MapReduce idea where you send the data and the functions to each individual workers. It reduces that down to just the data that you want, and then it merges it and aggregates it back together at the end. So a couple of things we really liked about it. It's got a nice Python API. So Spark itself is actually a Java application, but they provide a nice Python version, PySpark. It's got a pandas-like data frame syntax. So if you've used GeoPandas or Pandas before, you've got quite a similar kind of syntax in the idea of working with data frames. And it can also support SQL queries. So you can just put those directly into there as well. So if you don't necessarily want to write lots of like Python code, then you can just kind of supply it with SQL queries. And this is kind of what makes PySpark so great, is this idea of partitioning. So you're splitting up your data into multiple sections and then running each running your functions on each of those sections, and then aggregating it together. So there's a couple of advantages it can do. We can actually read the data in parallel. So if you've got your data source in a database, rather than reading it all in a single thread, you can get each worker to just read the section of the data it needs. Has this funky function called reshuffling, where it will then actually send the data that it has between each of the workers so the workers can run the data it needs. So you can imagine if you're trying to do like a group by function, it can send the specific attributes, each one to kind of each worker, so that can be optimized. And then we can actually write out the data again in parallel from each worker. So PySpark's great, but it doesn't really have the geospatial element, so it's fine if you've got flat tables. But for this, we want to do big geospatial joins. We've got lots of polygon on polygons, and that's just not going to cut it. So thankfully, there's an extension called Apache Sedona. So Apache Sedona just builds on top of PySpark and just adds all those geospatial elements that you're missing. So first off, it adds your geospatial readers. You can add GeoJSON, shapefiles, database sources, and it can also read well-known text, well-known binary. It also adds all of your geospatial functions, all of those classic ones that you sort of know and love, buffers, distance to distance, areas, and adding your spatial joins. Now, what Apache Sedona is really good at is being able to start partitioning your data by a geospatial location. So you can kind of see on the right-hand side there in red, we've got one of our data sets all across the country. And Apache Sedona will let us spatially partition that. So each worker might have one of these blue boxes and just have the data from that area rather than having to have the whole data set. So we can kind of break down our areas kind of on the fly, be able to run it as one thing, but it breaks it down. So yeah, I'm going to start putting it through together. I'm going to show you some of the code that we use so you can kind of use some of this for yourself. So yeah, kind of right at the start, PySpark comes with quite a lot of setup. So there's quite a bit of boilerplate that you have to run at the start. But it's just kind of bringing in all the various modules. We can import Sedona modules. This line here is starting to bring up a set up this Spark session. And the great thing about kind of PySpark is it sets up a lot of the background stuff for you, which is really nice in terms of, you don't have to worry about going, right, I want to send this data chunk to this worker, this data chunk to this worker. A lot of that it will do for you already. So we can just set up, create a config, and build a session. And then at the bottom there, we're having to add in our Sedona libraries. So again, because you're working kind of between Python and Java, you have to bring in your Java packages. It's just one of those things. I'm not a Java expert, just a bit of Googling, trying to figure it out and get that in. But that will add in all of our Java functions, all of our Sedona functions, and then we can add that to our Spark setup. Reading the data is really simple. So we kind of do that using normal PySpark. So we just set it up to using a JDBC connection. So all of your normal Postgres connection user details go in there. The couple of bits that kind of unique to PySpark over any other ones you might use are these number of partitions, partition columns, and your upper and lower bounds. So this is how it's going to split up the data to be able to read it in parallel. So here we're using the partition column of just the ID column, and we're going to split up into 37 partitions. There is kind of a reason for 37. I'll kind of go into a little bit later near the end. But just however many workers you want to do it in. And the upper and lower bounds is just allows Spark to work out where it needs to break it up. So it tries to break it up evenly, so it'll kind of split your upper bound into 37 sections and try and read the data nice and evenly. Once you've loaded the data, you can change the geospatial column. So you've got it coming in as a geom column, and we can read it directly as a binary. And then we can tell Sedona to convert that into a geometry that Sedona understands. So now we've got our data in, we can read both data sets. We're actually ready to start doing the spatial join. First thing we're going to do is convert to an RDD. RDD stands for Resilient Distributed Data Set. It's a PySpark term. You can go and do a load more reading into what that is. Personally, I don't even fully understand what it is, but it seems to make it a lot quicker. So yeah, converting data frames into RDDs. Again, Sedona provides a nice adapter function in there, so convert it into a spatial RDD. The next thing we need to do is just do a quick analysis of this. So that's where Sedona is just kind of getting the bounding boxes, finding out where all the data is within all of that data set. And then we're able to do our spatial partition on that. You can provide kind of what type of grid you want. Again, I think they provide 3 or 4 different grids, just figuring out which one works best for your data. Once we've spatially partitioned one side of the join, we can flip over to the other side, and we actually take our spatial partitioning from the hex side and apply it to our data. So you kind of already got those bounding boxes, so it means that actually each worker's getting the same geospatial location of data within it, so it's able to do that join without having to go across worker. And then we're able to do a join query raw. So there's actually, Sedona offers a couple of join queries. It's got join query raw or join query. Using raw, again, it says if you read some through the docs, raw allows to kind of avoid some of the serialization costs you might get between going from Python to Java. Again, just trying to sort of optimize it a little bit. Get a couple of options in there. To consider intersections, so whether you want the data just touching or whether it needs to be fully within the other data set. And also using index. Sometimes you don't need the indexes, and actually they kind of advise that at the time you've done the spatial partitioning, building the index, there might not be enough data in there to make it actually get a viable benefit. So again, a little bit of trial and error whether building the index is going to be helpful enough. Once you've done that, though, you can convert it back to a data frame for nice, easy manipulation of it and working it like a table. And so, again, they're providing an adapter function, so we can just put our results of that join query back in, and we get back out a data frame. So once we've got our data frame back, we're able to do some nice aggregation functions. So in this case, what we want to do is we provide each layer with a score. Previously, when we read the data, we're finding each layer with a score, and that's dependent on the type of feature that we've got. So what we want to do is aggregate it down for a single score per hex. And what we're doing in this case is we want to get the maximum score. So if we've got multiple features interacting with the hexagon, we want to take the maximum of them. We're also just doing a count and just aggregating the hexagons together. So when we're doing that group by, we just keep the original hexagon. And then once we're ready to write it back out, we can convert the geometry column back to the EWKB, so the extended well-known binary for PostGIS. And then when we write it out, and then we can just write it out into the database using kind of normal PySpark functions. One thing to note is PySpark doesn't really like the geometry column. So if you write it out in this way, it's going to write, if you're creating a new table, it's going to write that table out as, write that column out as a binary column. So you'll either have to go in afterwards and run an alter table statement just to convert it back to geometry. It's really quick because you're actually only changing how Postgres interprets the data, not actually changing the data. Alternatively, you can just truncate the table before you write it in and just use that table that already exists, and that will write it out into a geometry column directly. So you might be wondering, that's great. How do I deploy this? Am I going to have to work with deploying multiple machines? Is it going to be really that tricky? And there's a couple of options you can do. So you can run it locally. And if you run it on your machine, again, PySpark will turn each one of your CPUs into its own node within the cluster. So if you're just running this locally, if you've got 8-core machine, you've suddenly got 8 workers or maybe 7 workers and a manager. So you're able to kind of run things in parallel. But you can deploy this up into the cloud as well. So we're in AWS. So we're looking at using AWS Glue, which is Amazon's serverless Spark environment designed for putting all kinds of various ETL scripts up into it. So you can build them in there. It's kind of got Spark running under the hood. So when you put up your scripts into there, it actually creates a default cluster for you of 10 machines. So when you start running when you put up your script there and you start running it, by default, it will start spinning up 10 machines there and then, each with about 4 cores. So it gives you about 37 workers to play with, so it can really read that data quite nice and quickly. In addition to that, it kind of gives you a couple of options to scale up however you'd like. So if you want more machines, you can do that. If you want bigger machines, you can do that as well. It also gives us the ability to run multiple jobs all at the same time. So the way we actually did this for ours is we ran the same script about 60 times, but with slightly different parameters, one for each one of our data layers that went into it. So we're able to run those at the same time. One thing you've got to be careful of in terms of scaling it is actually starts becoming database connections. You can imagine if we've got 60 layers all running about 37, 40 workers, we've got like 240 connections to Postgres, and that's going to start hammering. Our DBA is going to be down on our back being like, why? So that's kind of things to be careful of, but we can run multiple jobs in parallel. Also, if you're a fan of using Jupyter notebooks, you can upload your Jupyter notebook into AWS Glue, and you can start running it in there, and it will actually start creating the session in there. There's ways that you can run your Jupyter notebook kind of locally, but it's connecting to AWS Glue, so it's using those kind of that cluster of machines to run it for you. So the outcome for us, there's a few little outcomes for us. One of them is our code is now testable. Previously, we had, say, 50 odd SQL stored procedures, and the logic in them was, sometimes debugging SQL scripts or going through SQL scripts and understanding what's going on can be quite tricky. We've now actually been able to take some of that out, put it into PySpark, and we've now been able to write test functions around all of that data, so we can kind of run tests locally, make sure we should be getting the numbers that we're expecting. We've reduced a lot of our complexity from, 50 plus unique stored procedures. We now have actually just two Python scripts, 2 of the PySpark scripts, with quite a lot of configuration, but we're just able to pass that configuration into those scripts and run those. We're now running cloud serverless, which is great because we're no longer stealing resources from other people in the teams. People can run FME workbenches if they want to, or run jobs in, just run complex SQL queries if they want to. We don't have to go in and slow them down or anything like that. And to be honest, the biggest outcome for us was the speed at which we were able to process all of this data. So for previously, if you remember, it was saying it's taking about 10 days. We can now rerun the entire data set in about 5 hours. And that's still with quite a low level of concurrency. We're only running about 5 layers at a time rather than trying to run everything at a time. So yeah, it's been a really big speed increase for us. Hopefully we're never having to rerun the whole data set every day, but even some of those bigger layers we can run pretty quickly. Just thought I'd quickly talk about some of the limitations of PySpark and Apache Sedona before you get too excited. Just to finish us off, debugging can be painful. You might be writing in Python, but that's going down to Java, so sometimes you might get Java errors brought up and you're a bit confused about where they've come from. Also, PySpark does a lot of query optimization under the hood. So when you're writing all of that data, so when you're writing your code, it might be running that in a slightly different order under the hood. So sometimes you might go, oh, I've got that number there, but suddenly it's changed to that, or you might make a slight tweak to your code, and suddenly it's taking a lot longer, a lot shorter time, or you might see sort of different errors. Environment setup can be a little bit tricky. Especially adding in the Apache Sedona modules. You've got some Java libraries to bring in. Some of those have to be downloaded separately and have to put those into the right places. PySpark generally comes with quite a bit of boilerplate code to get it set up. But generally we found once we've got that boilerplate, we can just start using that for each project. and it's kind of we can just use that boilerplate across each project and just copy the previous project and then delete the main bulk of the code, but use the start boilerplate. It's got limited geospatial readers still at the moment. So if you want to looking at this to run like ETL jobs of you're getting raw data from suppliers, then shapefile or GeoJSON are really your only options for reading flat files. Kind of confuses me because we're talking about big data and then shapefiles kind of limited in size. So I don't know why they went with that option. I think this shape's just popular for some reason. So yeah, I mean, I'm really hoping that they kind of expand that and start accepting things like geopackages or file geodatabase, and being able to read that would be amazing. But you do have options like GeoJSON and GeoParquet for those of you who are really kind of going down that cloud route. And then finally, yeah, docs are a little bit limited. So their docs are okay, but they've kind of got docs across 3 languages, Python, Java, and Scala as well. So sometimes they're a little bit lacking in places. And if you're looking for general support on the internet, then a quick look on Stack Overflow shows that we've kind of only got 47 questions about it. So not a lot of people are using it yet, which is in part why I'm here to try and talk about it and encourage other people to use it, and hopefully kind of get more questions, more people using it. Yeah, so that's it from me. If there's any questions, I'll happily take them.
We've got time for a question or two if anybody wants to ask a question. Wendy.
Yeah.
So you mentioned that you have originally kind of was using SQL to do your compute. So I'm just wondering if you are potentially using history for that, or is it, or are you limited to AWS?
We're limited to AWS. Kind of all of our infrastructure is sort of already in AWS. We have kind of looked at some of the alternatives to sort of BigQuery, but we've not kind of gone down into, haven't really taken deep dives into it. Kind of Spark is where we started at. But I think, yeah, Amazon does have its own version that we vaguely started looking at. I think we're at a point now where we're starting to kind of explore the ins and outs of kind of what AWS and sort of these big cloud providers are able to kind of offer us in terms of that query.
Any more questions? Okay, so firstly, Mike's slides will get uploaded during the break. So if you want to actually see his slides or take down, copy all that code, really geeky stuff there, by the way. I love it. Slides full of code, I mean, just
put them all as images. You've got to copy it all by hand. So.
Helen talking about the why, so Mike going right into the how. Black screens with white and yellow text. Wow. Coffee outside, cold water in the corner. I forgot to mention it. The door over there takes you to the toilets and you can come straight back in. It doesn't get locked behind you. There's also, if you're out there in the coffee area, you can go round and get to the toilets round the other side. They're over there. And I also forgot to say, there is no fire alarm planned today. That's good, I know. But it does mean if those sort of things go off, it's for real. Okay, coffee for 11:15. 11:15.
So 25 minutes.
How are you?
All right, mate. How are you?
I'm all right. Are we, am I able to do it with this and with speaker notes? Because I need to bring my bit of paper.
You might need your bit of paper. We'll try with speaker notes.
That's all right. I'm not a Mac head, so.
Okay. No, it's not that. It's in the browser anyway.
Yeah.
Yeah, so it should
I'm
work.
just,
Yeah. Okay.
you sort out what you've got to sort out first. Now.
Right.
Yeah, I'm not sure. I'm sure Yogesh will tell us.
What will I tell you?
where the photos are.
I have no idea.
Okay, maybe you won't tell us then.
There's a good photo apparently. There's Bangladesh. It says with hardship comes ease in 4 different houses. Yes, I see.
Okay.
So, just setting things up, have you poked people to go back in?
I have, yes.
Cool.
I have. They didn't take any notice, but I have poked them.
Yeah, no, that's the thing. So, Yogesh, you can use the clicker to go forwards or backwards. So it's the PDF slides full screen.
All right.
The microphone is the one with the laptop, so
Okay.
you're fine to wander around, but don't end up the other side of the screen.
Okay.
Stephen will introduce you. I'll give you a thumbs up when we're ready on there. If something is not doing what it's supposed to. And when we get questions, can you, the audience, the recording won't capture the question, so if someone asks the question, can you repeat it and answer it? Exactly. Yeah. We do have the camera on as well. Don't worry about it too much, it's not crucial.
All right.
Cool. Any questions or anything?
No,
you want?
fine.
Awesome.
Okay. So this is Yogesh, and he's going to be talking about the Hot Tasking Manager, a case study in mindfully modernizing infrastructure. Go for it.
Thanks everyone for coming to my talk. It's nice to be here among friends. This is going to be a mostly technical talk about Tasking Manager and how we handle the application infrastructure at HOT. A little bit about me. My name is Yogesh. I work for humanitarian OpenStreetMap team as a DevOps architect. I've been doing DevOpsy, SRE stuff for the past 10 years or so, more than that, if you count my sysadmin shenanigans. A word about humanitarian OpenStreetMap team. They're an international geospatial technology nonprofit headquartered in the US. They make tools to help crowdsource map data onto OpenStreetMap. Most of their work involves humanitarian mapping, meaning mapping for disaster relief, mapping for climate risk mitigation and things like that. They also focus a lot on community development, training people to map, training people in geospatial tech, encouraging people to map onto OpenStreetMap, generally giving out open mapping vibes to the world. All contributions from humanitarian OpenStreetMap team go to OpenStreetMap itself, and it's been the case so far. As a non-profit, humanitarian OpenStreetMap team, or HOT for short, they've had a lot of positive impact in the work they do. If anybody is interested in reading more about the impacts, the link is in the slide, and you can also scan the QR code. So today we are going to be talking about Tasking Manager, which is one of the most effective collaborative mapping tool in existence. It helps organized mapping at large scale happen quite easily, and all map data again goes into OpenStreetMap. Tasking Manager really, the tagline here really sums it up. It solves the problem of 1,000 people with the help of 1,000 other people. So usually we have an army of volunteers who lend a hand with mapping areas. I'll go into more detail about how this actual mapping activity happens. The meat of the talk is about HOT Tasking Manager, meaning HOT's instance of Tasking Manager. The application is open source. Anybody can run their own instance, and people do run their instance for various reasons. but this talk is going to be about how we manage our individual instance in our infrastructure. Hot Tasking Manager is used mostly in disaster mitigation and post-disaster relief activities. Usually, people like Red Cross and Doctors Without Borders, they are the ones who use Tasking Manager. It's got like it's really impactful when you look at the scope of the work. And I can give you a case study, like very simply, the recent Turkey-Syria earthquake. Tasking Manager was used to map an area at the affected area. Like we managed to map 2 million buildings, over 8,000 kilometers of roads, all contributed by over 9,000 contributors. The Hot Tasking Manager itself, the work it does is very simple. Organizationally, we do what is called a mapathon, analog to a marathon. Basically, like a lot of people mapping for a long time. Mapathon organizers, they could be individuals or other organizations. They basically create what is called a project, and the act of creating a project is called an activation. And they have their volunteers who will sign up onto the project, and they would start mapping. There'd be instructions and an area of interest, and they would be told what to map and how to map and all of that. The Tasking Manager instance has an inbuilt browser mapping tool, web app called ID Editor. But if for advanced mappers, they can also use their desktop editors like JAWSM, for instance. The tech stack of Tasking Manager is fairly straightforward. We have a static site front end built with React. We have a Python backend. We have Postgres database, which stores user information and information about sessions and things like that. It does not store map data itself. Map data is uploaded to OpenStreetMap as soon as a task is done. All of it currently is hosted on AWS. The keystone tech here is OpenStreetMap, which holds our data, and it also handles identity for us. So it's the single source of truth for identity. People log in using OAuth to Tasking Manager, and they need to have an account on OpenStreetMap to contribute. The current architecture is out of the way. All of it is on AWS. We have a static web app front end on S3, which is distributed by AWS's own CDN, Content Delivery Network CloudFront. The backend is on standard EC2 virtual machines running Python code. And there is we use database, Postgres database, standard issue, RDS databases here, and all authentications happen using OpenStreetMap, which handles identity management for us. We do have other tooling around our basic infrastructure. We have application performance monitoring using New Relic. We have log tracing using Sentry. We have AWS CloudWatch logs taking care of log analysis for us. The deployments are done using CloudFormation currently. We are moving towards a better system. CloudFormation is invoked by Subtle CI, which is triggered by a push in our source code version control. Database backups currently are both automated and scripted. We have a cron job because we have had some bad experiences in the past. So we schedule database backups using a cron job. But AWS also has its own RDS automated scheduled backups. Word of warning, when you delete a database, the automated backups, snapshots, they are deleted by default unless you, so I had to learn the hard way. Hopefully you can learn from our experience. So Yeah, so there are several challenges with the way the current tasking manager is architected. So architecture is quite rigid. We have the front end is more or less sound. It's on S3, which AWS handles for us. But the back end, the scaling is a challenge. Sometimes it scales slowly. Sometimes it scales down slowly. If it doesn't scale up fast, it's a performance issue. If it doesn't scale down fast, it's a cost issue. So we are having to find a good compromise between them. And we do use some AWS services that we used to use some AWS services that were legacy because inertia. We had to work a lot to keep up with the pace of AWS's development sometimes. And deployments are done in a very counterintuitive way sometimes. So each VM has to bootstrap using a Cloud Init script. It's super slow. Sometimes the VM is in a state that is incomplete and it does not send a signal to the scaler saying it is ready. So we have the load balancer scaling multiple instances without really any of them being ready. So infrastructure changes are not easy, were not easy, or were not fast. I blame CloudFormation for this because CloudFormation is a really difficult tool to work with. We used a tool called CloudFriend, which was developed by Mapbox, which is supposed to make doing CloudFormation easy. But yeah, it has its own limitations. So for those who don't know CloudFormation, good for you. And then we have our own security issues. Cloud security and workload security are two different things that need to be managed. We used to use Ubuntu 18.04, and then we moved after great difficulty to Ubuntu 20.04. It was not a pleasant experience because the application libraries that we depended on and the libraries that were shipped by default on the operating system were different, and we had to jerry rig stuff, and they are not pleasant at all. The planned architecture, it's planned being the operative word, but we do have a POC running. So we have moved to a serverless architecture. We have put in, I call it a best effort serverless architecture. We have used, we've had to make some compromises along the way. There are some trade-offs that are not really, that are quite specific to the nonprofit industry and our company in general. Front-end deployments are done by AWS Amplify. So for people who are not familiar with serverless architecture, it is basically outsourcing your sysadmin responsibilities to somebody else. That's all there is to it. So you just don't, the management responsibilities come down, and you don't have to worry about mundane things like scaling and maintaining the servers and patching and all of that. So what this really means is that somebody is responsible for your operational stuff at a certain level, and you can just worry about deployments and building your software. So AWS Amplify is a service that builds our front end and then generates the static site and then hosts it, and then does all the other stuff that comes with it to load balance when there is high stress on the front end and things like that. And for backend, we began using AWS Elastic Container Service. So I think the first step that we had to take was to containerize our backend, which basically was half the battle won. ECS, also known as Fargate, they call it serverless too. It does most of our application hosting for us, and we don't have to worry too much about scaling. We do have to think about the scaling logic, though. We have to decide what triggers scaling. Should it be the load on the CPU, or the number of requests, or the work that is done, things like that. And the database is now on AWS Aurora. It's a serverless database, meaning you only have to worry about the data. The server itself is completely handled by AWS. They make choices for what parameters should be based on loads. So for example, like if you suddenly get a lot of requests to the database automatically scales up, and the requests die down, the database scales down. This is also a good thing for us in terms of cost, because Aurora serverless only has, it is always at the right capacity or near the correct capacity that we need. So we do save a lot of money. Fingers crossed. So we also started using a lot of tools for security, meaning we started using scanners for our container images to see if there are any vulnerable packages, and to make things easier for ourselves to make good decisions, sound decisions for patching, and making good use of cloud security tools to make sure there is no like permission creep, or things like that. We also have monitoring sidecars, which basically get logs or metrics from the main containers and then ship it to Neuralink or AWS. AWS CloudWatch logs is just shipped directly, but for traces and metrics, we have sidecars. We also have way better VPC design, way better configurations for VPC. We are now IPv6 friendly for what it's worth. The network segmentation is done properly, subnetting is done properly. Instances that are private are truly private. You cannot SSH into them. And like the instances can access outside resources to pull in packages during updates if need be. And there have been like several advantages to this kind of thinking. There have also been trade-offs, which I'll speak about later. We have embraced serverless services, which means most of our services are handled by our cloud provider, and we only deal with pushing the software or like making decisions on how they should scale and things like that. Services scale way faster because we have containerized. That's the bigger point, but also AWS ECS is quite fast in scaling up and down, and that really helps keep the costs at bay. We have better networking and service isolation, so that the services that are public, services that are supposed to be public are public, and the services that are supposed to be secure and behind closed doors are. And we have converged on Debian Linux for everything, so we don't use Ubuntu anymore. We don't use Alpine anymore, even though people tend to praise Alpine for its small size, which is true. We have decided consciously to use Debian because it's just good for our consistency and making good decisions in terms of patching and making good decisions about dependencies and things like that. The developer experience has improved, meaning the developers can, whenever they want on a whim, just launch their own mini version of Tasking Manager that is temporary. They can just spin it out, run some tests, and then kill it whenever they feel like they're done with it. We have tighter error budgets. I'm just bragging in this slide. All our like the bars that we have set are higher, and we have proper service level SLAs, SLIs, and SLOs internally for now. We haven't made any grandiose commitments to our partners yet. We have continuous integration, and soon we'll have like proper actual continuous deployment. So people tend to club CI and CD together when they are actually doing just CI. We are doing just CI, but we have a solid plan to also use CD, meaning every time a developer makes a push, it will automatically be pushed into production after all the tests have been done and after we are sure that they don't break things. And oh boy, sometimes things break. So we also have better thought out observability metrics. So we resisted the urge to like think in terms of averages for everything. What is the average speed, average this, average that? And now we have begun thinking in terms of percentiles, like what percentage of users get to see the application in this time, and what percentage of users does the application load in this time, and so on, which gives us a slightly more actionable insight into the real-time performance of the application. We also have like better mental health because the alerts have come down. Earlier, we had our alerts so like sensitive that we would get Slack notifications and like alerts for every single thing. Now we have slightly better handle on them. We know what a real performance issue could be. We are still experimenting. It's mostly trial and error, which is unfortunate, but still we are at a much better position than we used to be. And our partners are really happy. We do get contributions from individuals as well as institutional partners. For example, Meta is a partner, and large organizations like Meta, they have their own internal compliance requirements for what constitutes like a safe contribution. And if they have to test a code and contribute it to them, contribute it to us, then we have to like satisfy some baseline criteria. For example, we used to have our AWS access keys on our continuous integration systems, and now we don't use OIDC, and they were really happy about that. So the bad news is that when you use serverless technology, you tend to get locked into a certain cloud vendor. And this is really not a good thing for a nonprofit because most of our funding comes from grants. So AWS gives us certain cloud credits amounting to a few certain thousands of dollars, $50,000 of cloud credits or $10,000 of cloud credits and things like that. True with Microsoft also and nearly every other cloud providers. But those grants tend to dry up very quickly when you're trialing and erroring and when you are like launching a new project and things like that. And cloud providers are really fickle. Their definition of philanthropy isn't the same as ours usually. So we have to be careful. We always have to be cognizant of the fact that if you get dependent on a cloud provider too much, then it will come back to bite you in ways that you wouldn't have imagined. So it's really a balance between cost, performance, and flexibility. And sometimes you just have to make a judgment call on what compromises you're willing to make. We started using serverless because we thought we can use cloud agnostic tools like Terraform to make sure that we can build the same application in two different clouds, and then we can just bring down one cloud's instance and then bring it up in another cloud whenever we feel like there is a cache inflow problem, as I euphemistically call it. But there have been like issues with that. Moving applications, lifting and shifting, as they call it, is easy, but lifting and shifting data is not trivial. So when you want to move data from two competing cloud providers, you will experience problems that are not documented anywhere. So fun stuff. Turns out this is not really a new issue. I picked this graph from the UK government guidance for managing technical lock-in in the cloud. We would like to be on the top right, but where we really are on somewhere here on the top left, unfortunately. But that's the status quo for now. Looking forward, we have some grand plans for our application, which we are hoping to do everywhere. We are going to use open telemetry for shipping metrics, logs, and traces. Open telemetry is like a standard protocol which you can use with any vendor. Like most of these vendors, including Neuralink and Datadog and all of these people, they've begun to implement support for open telemetry, which really make things easier and standardized. So you don't have to incorporate in your code Neuralink specific stuff only for a partner to be unhappy with it. So this really solves that problem. Infrastructure policy enforcement using OPA for people who do server admin stuff who are not familiar with OPA. I highly recommend. It's a domain-specific language called Rego, with which you write policies, and you can just evaluate those policies and apply to your infrastructure. In this case, we use OPA for Terraform. We don't have a really robust OPA policy yet, but OPA looks at things. Oh, this should not really be open to public, and then like if the policy states that, and Terraform's output breaks that policy, then we would get an alert, for instance. And container orchestration is a really nice thing to have. I shudder when I say Kubernetes once in a while, but yeah, we do plan to use Kubernetes are an equivalent for orchestrating our containers, because it sometimes really makes things simpler. And in our quest for cloud agnostic multi-cloud architecture, this really is the way to go. And blue-green deployments, we would really like the ability to like make a change, deploy it to the public, and then like have a 10% of our users be the guinea pigs for our fancy new changes. And if things don't work out, we need to roll back. And we have had some challenges with rolling back database changes. So we have been doing some research. And then workload security using proper container image scanning and hardening, meaning like nobody runs Bitcoin miners on our non-profit container servers. So that'll be really sucky. If you would like to get involved, the tasking manager code is completely open source. It's on GitHub. You can go to github.com/hotosm. That's usually our handle everywhere, hotosm. And tasking-manager would be the URL. You can review the code, file bug reports, send pull requests, whatever your jam is. We are really friendly, and we would welcome your and be grateful to your contributions. You can also participate in working groups. So one of the technical working group is about to happen this month in September 21, if I'm not wrong. You can also connect with us on Slack. We have our own Slack. All of this information is in the QR code, or you have the link for those who can't scan it, autosm.org/get-involved. I would really like to thank several hot staff, present and past, especially these people. Kathmandu Living Labs is a company in Nepal, and we got help from them. We contracted them for several improvements to Autoism, and they've been amazing. And Taylor and Sam, they've been individual contributors representing different companies. They've been super helpful also. And there is also a QR code if you want to see who has been contributing to Hot. There is a bot there called DependoBot, which has been like sending us a lot of automatic patches. It don't count. So otherwise, thank you so much. And if you have any questions.
That was brilliant, Yogesh. Thank you. Has anyone got a question for Yogesh?
Yes.
Two. Go on. Jez.
I know a lot of people think at getting people who are actually in the local area to use apps. Does it make a difference for your support? You've got to do it worldwide.
Sorry, does it make a difference for what?
Well, has it affected running the systems?
Right. So the microphone, the question is, I think, Hot has local mapping efforts. Is that the question? And what effort, if any, what impact, if any, does it have on these systems? That's right. So we are developing a tool called Field Mapping Tasking Manager, which really helps people on the field map areas of interest. It's slightly more granular compared to Tasking Manager. We consider it a spiritual successor to Tasking Manager. But Tasking Manager, I feel, has its place for the at least in the near future, in the next few months. We also are developing. We have an AI project. Again, I don't really like the term AI. It's called FAIR, FAIR. So what it does is it builds local models for areas to learn about how artifacts look like from satellite imagery and drone imagery, and then like it helps assist human mappers easily and quickly map. So it basically auto annotates items in the map, and then you can just either say yes or no to those things. So I think FAIR and FMTM have a role to play in the future of Tasking Manager. In what form Tasking Manager will survive the next few years, I'm not sure. Maybe it will be like replaced by FMTM, not really certain. But I do think that for the next half a decade or so, it's not going anywhere.
Excuse me, sorry. I just sent a WhatsApp message to Arno to check on something, and I turned around and he was sitting there nodding at me, answering. Sorry, carry on.
Yeah. Anyway.
You mentioned you kind of reluctance or trying to avoid vendor lock-in. How did you balance that with using something like AWS Amplify, which locks you in quite a lot nearer?
Yeah. So the choice was to use services that have analogs in other cloud vendors. So, for example, if I use AWS Amplify, I can use something analogous to S3 and CloudFront in Microsoft Azure. And then what we need to do is we will build a Terraform module for the application in AWS, a Terraform module for the application in Azure, and then we just keep them on hot standby and keep them up to date, make sure that they are API compatible with any changes. And then when the Felota hit the fan, you bring down the application on one cloud, or you bring it up on the other cloud and then bring down the other application. And then you just have to test it very, very well. But moving the data between clouds, like for example, like taking a PG dump or moving Postgres backups across clouds has always been a pain. So Microsoft has a tool and AWS also has a tool to ship data, but they only focus on bringing data in. So I have to move the data to a VM, from VM to S3, and from S3 to a blob store in Azure, and then to a VM, and then to Azure's database. They do have tools. We have always found bottlenecks in those tools, and we have requested AWS support. There's not been a definite resolution yet, but that assumption that tools like Terraform can help us has been shaken with the news that Terraform is now going, shifting to business user license. I don't know what the future holds, but we will be exploring other tech to see if we can make this easier. Yeah, otherwise we have to multi-cloud approach is not really a thing, because you cannot use two different components of the same application in different clouds, because they'll just empty your wallet in no time, because clouds, they are smart. It's free to get data in, but it costs a bomb to get data out. So that's always the case.
Okay, thank you.
Thank you.
So next up we have Mike Saunt. Let me just get his slides up for him. There we go. And before I do anything else, despite my efforts to silence it, WhatsApp on my computer has been binging away, driving you all mad. So I've now shut it down, so that will hopefully not happen. Oh, right, okay. So Mike is the managing director of Astun Technology. Astun are a national sponsor, so the whole
I'm not sure that we
Yeah, go for
we're
it.
live. Anyway, one of the things I did want to mention, I think it's quite apt that we're in a concrete building at the moment. I've been watching the news lately about all that sort of stuff. On the other side, it looks a bit dodgy, but we'll not worry about that too much. What I'm hoping to do is sort of bridge the gap, because open source has been confused before. It's also open data has been a big factor. Open source is always open standards. That makes the data open. So there's some of the things I wanted to just be touching on. And it's going to be a bit of a history lesson. Like I say, it's not really technical. And I think it's important to look back as well as look forward, because you might learn some things. I haven't got too much past 2013, because there's actually, I think, is it a keynote or panel discussion later? But I've got a few bits, not massively. So with the normal thing, the people want to put their hands up and they want to stand up. You've got to get people's participation. So let's put our hands up if people know who that is. Okay, so put your hands down. So pick people up if you were born before 1976. Sorry, I was up and I'm coming down now to show my age. So
Put them down if you were born.
yeah, so everyone else keep your hands up. Sorry, if you were born after 1976, keep your hands up. So in 1976, there was quite an there's a letter that was sent by Bill Gates to hobbyists. His dismay of software piracy. It really that's when we started Microsoft, set the scene, set their stand, so to speak, of what they, their view of licensing. Okay, keep your hands up, peoples. So anyone who was born, you were born after the 28th of November 1990. I didn't think we possibly. Well, you can put your hands down now, because I don't want to single people out, but that's a significant date, I think, because that was when Maggie Thatcher sort of been Prime Minister and the leader of the Conservative Party. Those who lived over here, that's just a date and thing. It was also, I was in Australia, not that exact date. I started working for a company called Peripheral Systems that became Mapping for Australia. And that, I can't remember the name, but about doing some mapping stuff nowadays and how Google Maps do things. I started off digitising maps. I left school at 16, and that's how we did. We put a paper map on the board and follow the routes around. So I didn't do that for too long. Became team lead and then started getting into data processing and doing stuff like that. But enough about me. My own real introduction to GIS was through a company called MapInfo, who are no longer with us. That's actually where I met Stephen. He was a competitor as well in those days. And that's then back in 1993, that was pretty cool, that became multinational. But also, I wasn't aware of open source in those days. I was aware of freeware and shareware. People remember that. And these are the four little bits that went on Windows. So, this is 2001. So this is all sort of relevant. This was Steve Ballmer, so following on from Bill Gates' photo, Steve Ballmer, he was the CEO, I think, at the time of Microsoft, and he made this statement that he thought that Linux was cancer. What I really like is that it's hippie GPL. I don't say shy, but I was going to say that was rubbish.
Sorry, carry on.
Right, I'll carry on.
Good. Ignore me.
And that's where I think that there was a term that was called fear, uncertainty. Just going through the years, and hopefully there's some relevance, touching on database standardisation, community building in the UK, how we came about to you guys all being here and around the country. It's quite important to understand this sort of stuff. Well, I think it is. So, I've quite a lot to talk about the early years, and then I'm trailing off a bit towards the end. So, well, that's because of the 2013 onwards, an event then is going to be discussed later. So early on, I came about it through something called MITab. I used to work for a MapInfo reseller, or I was part owner of a MapInfo reseller. You couldn't get in to change the data format. It was all locked into the tab format. And I came across something called MITab, which was a means of being able to read and write MapInfo tab files, as in the name. That was quite a big thing. At that time, I was more into the open data side, trying to get the data formats converted than I was into open source per se. 2015, I started, 2005, sorry, I started a company called Astun. Yeah, I wasn't aware of any other open source geo companies in the UK at the time. Originally, it was set up to put embedded maps into CRM systems. That's what I was looking to do, and geocoding various things like that. I also took a product from my previous company, which actually is the main product that we sell nowadays to local authorities, not quite selling that. That was based on something called MapInfo Mapping Stream. That was just a web server piece of software. It's cost 10 grand a CPU, if I can remember correctly. So if you had 2 CPUs, it was 20 grand. It was expensive stuff. Everything in those days was run on Windows, Microsoft Windows Server. There wasn't even the concept of the cloud that had been advertised anywhere in those days. So I'll put this slide in. So if you look up here, there wasn't OSGeo came into formation in 2006. There was lots of chatter and talk about it. That's the original logo that's on the right at the top. It's been modified over the years. Lucerne in Switzerland was the first Phosphor-G, which is run by OSGeo. They sort of. But it has a big thing is actually it had some backing. I'm not sure if people are aware of this. A company called Autodesk. They had map guides. They put 50 grand in, just in US dollars, just to help get it going, because they were trying to promote something they had to go open source. It just shows some of the background. One of my little notes, I think the first state of the map was in 2006 or around that time, something like that. Maybe. I think you'll know this, probably a lot of you haven't seen or remember that user interface. That was Google Maps originally. Now, I think it was 2005, I think it was 2006 that it came out in the UK, I remember. I do remember that geocoding came along, it means being able to do that, so it sort of killed off what I was trying to do with embedded CRM stuff, that people just started using Google Maps. We had 50 plus SMEs who were using it, but that laid down the wayside. So I was concentrating with the business on trying to build up what we do for local government. Got into PostGIS, that had just been released in 2006. It had 6 release candidates over 5 years. So it shows how rigid and how stable I think PostGIS is. It's a solid bit of kit. I think you're probably aware. This is some archaic old views of how things were in those days. This was the first, not official UK chapter meetup. It was a really, I can't even remember where it was, but I know it was near Stansted. It's really classy near Stansted Airport. That's what I do remember. It's a colleague of mine, Joe. Sunak, who's at Suchit, sorry, who's at
Sunak's the Prime Minister.
Yeah, that's what but that's a surname and anyway, that's me with that beard. That was us when we met up over there. Like I said, there wasn't even a local chapter in those days. I told you this wasn't technical. 2007, we embedded PostGIS and Postgres into what we did. And then 2008, we brought map serving, which replaced what we had, which had Map Extreme inside it. And our first client, who's still a client now, took that all on board. And I remember them saying, "What's the difference?" I said, "Well, about 10 grand CPU." They said, "All right, we'll take what you put in the map serving side." So this is how things were promoted in those days. So it was quite archaic. You remember the web from those days? It looked big images and things. There weren't nice AWS logos or system architecture diagrams floating around in those days. So got through that piece. Now trying to go to the document. It's not quite quick. I'll slow myself down when I talk. So this was in 2010. Ordnance Survey, where we are today, they released open data. So it was actually, I don't know whether a lot of people know, it's funded by central government, as with most things with the Ordnance Survey. I won't go into that, about their monitoring, how they do things. But basically, they got 20 million for 10 years to release these products. What you might be able to see here, that there's a lot of things out here that open. So it's not just open source. I think it's really important to remember this. I said it earlier on. It's about the data as well. It's about the standards of how things are used. You can see quite a few things have gone on over these years. I don't know if you remember Gordon Brown, people who were here. He was the Prime Minister. I won't talk about the government from here on. That's all right. We're aware of those. And I won't go explicit, honestly. So this is something that we did back in 2011. It's an open source project called Loader, and it had an exclamation mark, so we wanted it to be a bit like Yahoo, with the exclamation mark. It was built by a guy at Astun called Matt Walker. Walker Matt is his handle. It was an open source GML translator built on top of OGR, which is a set of tools that people are nodding their heads. You're probably aware of that. Just a little tidbit with that. Nobody knows what OGR stands for. It's not nothing. It's just because it's that old. But anyway, and actually, the proof of concept I did, I was able to translate some data, but Matt made it a proper thing that could do. I wrote batch files. He went to it out. We worked with the Ordnance Survey on that. I can't remember the guy's name. It's Tim Martin, I think. Tim Martin. He and got down. He helped us to make sure that we translate all of the stuff in Mastermap. That was, I think it's 500 million features that get loaded. So there's a lot of nuances that come along, and we were able to get it down to 40 hours, which in those days is pretty damn fast. That's on a single machine running. We then modified over the years so you can run in parallel on different machines, not with Apache Spark or Scala or what we talked about earlier. So that's quite a big thing for us. Another thing with that is there was a UK open source company, I won't name them, I'm not sure on that. They forked it, they used it in another product, which is fine, but it's always important when if you're ever using open source and you want to make modifications, I think it's really good to give attributions to companies that put time and effort in, like I've just talked about the OS, but also that it's about collaboration. If you got code, you might not think people want to know what you've done to it, but maybe there'll be an advantage for the wider community if you're sharing that. I'm actually aware that I've done with another product. I'm not going to, I'm still honest. It was, that wasn't related to us. 2012, Open Data Institute, everyone aware of them? If you live in the southeast near London, they're really good to go to. They have lots of talks on, very informative. Big names were there. Tim Berners-Lee and Sir Nigel Shadbolt, who set that company up. In 2012, we then actually built a national cloud-based tile server for Ordnance Survey data. The Ordnance Survey didn't have their APIs in those days. This is over a decade ago. It was based on the TMS specification, which is the tile map service. That was set up by OSGeo, and that was again before the OGC had the standards to work on. And that took off. I've got a couple more slides. That was written by Matt Walker as well. It's a lot of credit. And what I really like about this are actually the icons, which is really basic. It sort of describes it very well. The happy face at the end. That's what he put together. He gave a talk, actually. It's I've got it written down somewhere, but not on here. I think it was W3G or something like that back in those days about this. And it was quite, there weren't many people doing this sort of stuff. All run AWS. 2013, oh, no, still in 2012, still nice icons. If any of you do any web mapping services, Map Proxy is a really good bit of kit, just so you know. That's to do caching and various things like that, if you ever do that sort of stuff. That's as far as I go technical nowadays. There's a bit of uproar in 2013, which is all related to, there was nearly what was termed as a coup. It relates to the to OGC and a small geo company called Esri, who put forward the GeoServices REST API, which was quite ahead of its time really. REST wasn't really taking up too much in those days because we had WMS and Saunt and all of this other stuff. But basically, the really good thing that came from this was that there were at least, I think it was 137 signatories, which most were from the OSGeo community, saying that this was the wrong thing for the OGC to do. They were being hijacked by Esri. It never actually got to the vote. There was a vote put forward to happen. It got cancelled, and the rest is history. There is actually now an OGC rest API. It took a little bit longer to get there. But again, I'm just trying to talk about some of the history of stuff. Whether you think it's relevant, I'm not sure. This is why I'm sort of slowed down at 2013. That was a big deal because it was a global FOSFOR-G. There wasn't a UK chapter at the time, local chapter. So it's a significant milestone. What's the notes there? I can't remember what they were for. Don't worry about that. I'll keep going. Anyway, that was a really good event. It was pretty huge. It's not Nottingham University. You were involved with Stephen. I think others you were as well. I can't remember everyone's names. Anyway, now this one is another interesting one. Going back to Steve Barnum thinking things with cancer, and now Microsoft, I think they've really changed their view of things. They still do their licensing thing, which is fair enough. But this is all about that they say they love Linux. It's a go-to for them on Azure. I think a lot of people do use Azure for that. 2015, we started using GeoNetwork quite a lot. So that's a metadata tool. People hate talking about metadata. They often go to sleep when we start talking to them about it. It's pretty important stuff to understand. Metadata maybe, I'm trying to think of things back to the previous presentation, you could be using metadata to bring up when things are last being updated all in an automated fashion. People really like to understand that sort of stuff and they dive into bits and pieces. There were 30,000 data sets that have been released for metadata in the UK, 20,000 were open. We embraced it, worked with the Environment Agency. They had a lot of data they needed to release. Now, this is, so 2016, the OSGeo UK was formally formed as an unincorporated organisation. That's a little screen, a bit of the actual constitution. You can find it on the internet. It was actually signed in 2018. This is, like I said before, this is how come you guys are all able to come here today, this sort of thing. So I'm just flying along here, which is good. I think I'm flying along. You're flying. I'm flying, apparently. That's good. So this is DEFRA, trying to be funny there, with the hybrid approach. They implemented a data sharing platform with some metadata that was within it, so that people could find data and share it. It was a hybrid approach. They had Esri mapping tools in place for providing views of the data and what have you. And they also had GeoNetwork embedded within there, within the metadata, and that was all feeding in from all of it, but a lot of it coming from the Environment Agency, because they're one of the larger metadata holders for the Ordnance Survey, for DEFRA, sorry. 2019, the Ramblers embarked on transformation with open source geo at the heart of it. They've now gone on to, so they've set up what they call a Geo Hub that's built on top of Postgres. It's got GeoServer running there, and that's a really big thing for them. They had a few proprietary applications they've now moved away and made them all open source with what they've got, what they're using for. Just a tidbit, I've got a couple of notes on this one. It uses AWS Amplify nowadays for some of their front-end stuff. I don't know the details, don't ask me about it. But we do a lot of work with them. We're a bit like a geo agency in inverted commas, and I think of that because we want to retain with them that we're available at all times as a business, and that's changed from how people used to be. It's all project work, whereas nowadays people don't want to have to bring people in and teach them all up about geo, because I heard someone earlier saying that people say it's not special, but it is. It is still quite niche, trying to understand what's going on with geo. So we come in and we help them do what they need as a bit like a marketing agency, might do with business. Now this one's a big one. That's COVID, apparently. So 20 to 22, Highways England had a GeoServer application that had been embedded within them. So GovScot had renewed a contract to have an open source GeoNetwork for their spatial, Scottish spatial data infrastructure, which is their metadata portal. That's quite important. What I'm trying to highlight here is that there's quite a lot of use of this open source, even if you don't know about it out there. And also Galbraith, which is a company that, I don't know whether you've ever seen On the Map, which is like a property portal. They provide data within that. They do a lot of estates management, and they've got a lot of open source. They also use Esri quite heavily. And this is part of what I think of a hybrid approach in business now, that people say what they think are the best tools for the job. So it's not, I wouldn't like to say that, going back to the cancer, being on the Linux is a cancer, it's not about being, I've always been an advocate, it shouldn't be an open source necessarily hippie for the sake of being hippie. You've got to think about it from a business perspective, and what the advantages are for you as a client or not. Really coming close to the end now, so you'll be happy to hear that, I'm sure. There's a company called Ocean Winds and Aviva. As a business, this is a little sales pitch, but we provide what we call support coverage to these businesses. Ocean Winds, they run everything on Azure. They run heavy duty, I think the Azure name for it, but basically Postgres database with Postgres running within there. We provide support coverage, priority support. If they need it, have any problems, a bit like what I was saying about the agency, they can call us when they need to, and we'll respond within a certain time period. It's quite a big deal because we've got an SLA in place that we are there to respond. We have multiple people who are on the help desk who have got the skill sets that we need to make sure we can respond in a certain time period. Again, it saves them money. They don't need to employ people and worry about people being on holiday, having cover internally. We take away that headache. So I'm coming to the end now. Back to that sort of slide, and I wanted to just mention that I think it's important to look back at how things have been. It's not just tech, but also because it's not just tech. It's not just the code that counts when you're doing open source. And this has been talked about many times over the years, but documentation is really important. If you can help with just doing doco, that was a really good thing to help if that's what you're trying to do. Testing, organising events like today, and also providing advice. Somebody else mentioned Stack Overflow earlier, and that's where it's just any experiences you've got is really good for the community, so to speak. Now, I'm not trying to be Mr. Jobs, but one more thing. Some of the business models of things, one things I wanted to mention is there's a bit of a view now that we've adapted our business models over the years. So we've gone from trying to do embedded CRMs and various things like that. We've gone from using Mac Server and various things, and doing support now for generic things. But there's more and more of a view of mine anyway that you should go into partnership with other companies, and it's normally all to do with a handshake. You know, if you need to write down a contract and refer back to the contract, you're up the creek already. So we've got an MOU we've set up with a company in Switzerland. They're the authors and the main advocates of a product called Viewpoint. I don't know if people have heard of that. So it's a mobile app. Basically, we're working with them so we can provide that to our customers in the UK, but they've got the knowledge and they understand that they'll be able to provide us with support. But also, if the customers have any changes they want to make, we can take that forward. And I think that is the end of my very brief.
Perfect. Got time for one question for Mike, if anyone's got a question. No questions? Okay, Mike, thank you. Right, let's see if we can do this. So next up, according to my thing, it's Ali. Let's just see if I can find your slides, Ali. That would be a great start, wouldn't it? Ali Cass, there we go. It's brilliant when things actually work. Fantastic. Great, that clicker work for me as well, that? That click will work for you? Yep. You've got 10 minutes. Okay, great. Yeah, hi everyone. So I'm a data engineer at a company called Transition Zero. And my purpose of the talk today is to tell you about how we're using FOSS4G to build our future energy outlook platform, also known as FEAR. So a bit about us. We were established in 2021 with the main aim to provide energy systems models as a service. So we're really trying to foster an environment of open data, open models, and ultimately build up a global standard for energy transition planning. So first of all, what is an energy systems model? It's essentially a tool that's used to understand and plan for the future of energy systems. Typically, they can be used by countries, governments, for example, to understand the cost of a climate policy, or used by corporations who are trying to understand their route to net zero, as well as by investors who are perhaps looking to find the best location to put a wind farm. And each year, there's trillions of dollars of money spent around the world in this sector. So really, the question is why FEAR and why now? Well, lots of countries have pledged their ambitions to reach net zero. Many have implemented policies already, others have policies in the works. However, they don't necessarily have the plans in place to get these policies into action. And as they try and develop those plans, the information that they're trying to source is often it's not transparent, it's pretty impenetrable. And this is because traditionally the energy systems modeling world is not very transparent at all. And the systems are black boxes, and while the results will be published, often you won't get the data, you won't get the methodology, so it makes it incredibly difficult to try and challenge assumptions, interrogate the results, and so yeah, really we want to move away from this to a more open and inclusive environment. Just an example of some of the data that typically goes into these models. We have data that's focused on the different energy sources as well as different energy demands. We have power grid data as well. And we also have market data, so like local markets and global markets. And what you can notice from the map, obviously, is that a lot of this is geospatial data. So we're working with lots of geospatial data for these models. So our solution was to build our future energy outlook platform. And ultimately, it's an open platform. It provides a modeling suite as well as data itself to really empower users to explore different scenarios. So it can be like planning their path to net zero, exploring new capacity expansion. And typically, as with most analyses, gathering data can be quite laborious and very time consuming. So as part of this platform, we're building up a data catalog that our users will have access to. And we're doing this via web scraping, so getting published market data and power generation data. We're also using satellite data and machine learning to supplement these data sets. I'll touch more on that a little later. And we also have local partners and analysts who provide key local data import and data verification. So on the opposite side, we have the interfaces. So how do people access this platform? We have a web app, which is our main GUI. It provides a good interactive visualization of the results and is good for non-tech users. We're then in the process of building a Python client, which will be open sourced, and that's more focused at tech users who want to get a bit more of an interrogation going. And finally, we also have blogs and reports. So these are the bits that we can actually get out and get in front of decision makers. So this is what it looks like at the moment. We've just got the web app showing results for a model run in Indonesia, and this provides an interactive visualization and information. So we can see some summary stats there, giving broad information around the total cost of the system as well as the total emissions that are involved. And you can access that currently via the URL that's at the bottom of the slide there. So I think really the main part is how did we get to this? And so we are using a microservice architecture built around 3 core services. We have the model service, which is focused around the model parameters, the configs, and also the results of the models. We then also have our node service, which is more focused on our sort of asset level data. So it could be things like the particular location of a substation. We also include market data, and an example could be the price for building a solar panel. And then on the other side, we have our geospatial service, which is our core raster and vector store. We are providing geometries for the point locations of certain assets and nodes in the power grid. Geometries are, for example, regional boundaries, as well as raster data in the form of land cover and things like that. Now, this is all deployed in Google Cloud, and all these services sit behind a gateway. And also behind the gateway, we have a server-side cache, which is implemented using Redis. Our authentication is handled by Auth0 externally. And each of the services follows a similar pattern. We have a database layer, which we're using Postgres for. That's implemented using Google Cloud SQL. On top of this, we have our API layer, which is a fast API application. And this is deployed using Cloud Build and Cloud Run. And for the geospatial service, we have a few more components which are key to working with geospatial data and operations. So we've got PostGIS on the database layer, and we also have GeoAlchemy on the API layer. So that's broadly what the architecture looks like. A little bit about the geospatial API layer itself is that when building this initially, we focused on custom code, building up the core CRUD routines and endpoints that supported the platform, the MVP at least. But as you continue to develop this further, we want to make sure we're implementing standards and can really make sure we have maximum interoperability in the open source space. So naturally, when it comes to geo and REST standards, we've been looking at the ODC API standards. And our entry point for this was actually the great project TPG by Development Seed. That itself is a fast API application which provides the standards, the ODC API features and the tiles standards out of the box. Those are all the GET requests, so the read access to the data, whereas we also need to have write access and have the sort of ability to do the rest of these CRUD operations. And so we're supplementing this with custom code, and in developing the custom code, we're delving into part 4 of the features API, which I believe is still in draft, and this is where the rest of the CRUD operations are defined. And finally, we're also working on some fine-grained authorization for some of our endpoints as well. So those are a few of the challenges. We hope that we can contribute things back to the community, but likewise, if anyone else is working in a similar area or has faced these challenges, it would be great to chat. Another component of our system is our stack. So this was built using PyStack, and it was a way to expose our raster data that sits in our Google Cloud Storage bucket. So we've stood up an internal application based on Radiant Stack Browser project, which again, is a fantastic project. And so this is allowing our team internally to search and browse our raster data, which includes typically like land cover data sets, as well as some of our machine learning outputs as well. And hopefully we will be at a point where we can provide our open data via a stack. I mentioned a little bit about machine learning. So we are carrying out our own solar plant detection using Sentinel-2 images. And really this is important for us because existing data sets where we would get this information from are quite quickly go out of date and are often incomplete. So we're supplementing the data with our own detections, and the actual data sets that are published also really struggle to keep up to date with the rapidly expanding infrastructure. In a similar vein, we're also detecting elements of the power grid, so we're trying to detect extra substation nodes and power lines, and Again, this all comes down to supplementing existing data to build up the most accurate picture we can get of the bike power grid. And obviously, the more accurate we can get that, the more accurate our results will be. So looking to the future, our timeline. So we've recently started releasing monthly tech blogs, which are available on Medium. We're planning to launch the platform officially at Climate COP at the end of November. So it's a busy few months for us. Eventually, we will open source our Python client. Again, currently a work in progress. And also, we're hoping to have many more open source contributions, which will be accessible via GitHub. And finally, the Theo URL there points back to the web app. And we're going to be continuing adding more model runs and data to the website, so it's a good space to watch. So finally, I think it's important to state that Theo is FOSS all the way down, and it's built upon some really incredible work from the FOSS4G community. And so we're really keen to collaborate and contribute where we can and give back. And we're also users of our product as well. So everything that we're building, we're using internally. So we're really striving for a good user experience, both from a technical standpoint and a non-technical standpoint as well. And then finally, the ODC APIs and FAST API go really well together. It's been fun to implement some of these things. And that's it for me. Brilliant. Thank you. Perfect.
I'm not going to take any questions.
Okay.
You've used your time.
You used your time perfectly.
So next up, we've got Ivan on spatial interaction models for active travel computing. Commuting. Yes.
Just try something with the presenter now.
Hang on. Yeah.
Yeah. Okay.
How did you do that?
I'll just show it like that.
Okay. You okay with that?
Yeah. So how do I can change it? Oh yeah.
Yeah. I'm not sure. Does this work? Yeah. The clicker works as well.
Okay.
The right arrow will move it forward.
So hello, thanks for having me. My name is Ivan. I'm a researcher at the Center for Artificial Analysis at UCL, and I've been working this last almost year on developing spatial interaction models, which is not something new. But the kind of new part is applying it to active travel commuting. And why is that? Well, mainly because we're seeing a sort of transition in the preferred mode of transport from the user side, from the commuter side, but also from the city planner and city officials side. There's many reasons to that. Among them are all the sort of problems that cars bring to cities, that are pollution, noise, congestions, requirements for large parking space, collision dangers, and basically active travel is a simple and very powerful alternative to private vehicles that kind of solves all these problems. So our aim is to kind of contribute to some quantitative models of active travel, and we focus on commuting because that's what active travel, spatial interaction models work the best. So as an example, in the London plan, there's like throughout it we can find mention of walking and cycling, and part of it some important element of assessing areas. So existing and planned transport networks, particularly cycling and walking, and the connectivity of these networks. So basically, simply put, we're trying to understand how to get from this or this to this and this. And so on the left is some footnotes from Roman times, I think, they found on MoMA's website. And so the context within CASA, within our lab, is that we have a model that already runs a few modes of transport, including cars. So the model is called Quant. So ultimately, the goal is to have an open source accessible tool, web-based, that allows to run scenarios of transport change or employment distribution change. And the sort of scale of it is aims to be pretty much unlimited and be countrywide at least. And of course, the methodology is to have a bunch of open source reproducible software tools, and at the same time have a sort of scalable enough workflow. And so our work was quite dedicated to sort of benchmarking the various tools that exist and developing some new tools in the case where we couldn't find what we needed. So the task of building a spatial interaction model from our own investigation goes down to having the right network representation of the road network as a graph. Then comes the routing that you do on the graph, and then the final bit is the spatial interaction model, which is basically an equation that you add to the plot. So on the network side, we kind of identified like all the main open data sources that we have, mainly OpenStreetMap Ordnance Survey, and we can see the kind of differences right away from Ordnance Survey in red and OpenStreetMap in blue, and the map below is the sort of expected coverage of each. So we see that Ordnance Survey's open source road network is more adapted for cars, while OpenStreetMap is a bit richer and more diverse, especially in certain areas like Stratford, where we have a lot of pedestrian paths and cycling paths. So our kind of goal was as well to benchmark all these kind of elements and see their impact. Now, if we look a bit closer on OpenStreetMap, through the many packages out there, in this case OSMNX is a Python package, you can filter out certain segments, and it relies on the OpenStreetMap's internal tagging system that we already mentioned today. And so, although it's very well sort of tagged, we still find some problems that end up potentially messing up the results, because, for example, we see the two foot tunnels, the Greenwich and Woolwich foot tunnels, which are only included in the pedestrian network profile, but not in the cycling network profile, although in reality it's of course used by cyclists as well. So we cannot really fully rely on this tagging system. So in the end, we kind of opt for different types of networks and test them. So the OSMNX package helps us to get the whole network, from which we remove motorways because they're illegal to cycle or walk on, and keep all the rest. But we also do this cycling and walking profiles to test them. And from OS, we get the full map that I showed earlier. And we also test another thing, which is weighting different segments based on the preference of such or such mode of transport to take it. And this is done. This is implemented in a package called Dodger in R. So we use their weighting profiles. Now the next step, once we have a set of networks that we can test, is what are we routing actually in terms of nodes, from which node are we going to which node. And for that, the common method is to go for the geometric centroids, and we test this, but we also thought that maybe there's something to do here a bit extra, and so we decided to add two more types of centroids. The network centroid being centroid of the road nodes within urbanized areas. We exclude all the parks, water bodies, places where we don't find any potential employment or residential locations. And we also thought that it would be interesting to look at a pair of points that we route, which are on the one hand population weight centroid, so as the origin of our flows, and the second is workplace zone centroid. The workplace zone is something that the ONS does, and it sort of assigns people to certain employment zones. So we took these, aggregated them on MSOAs, and just put some right in that. So we end up with a pair of points, and we route from one to the other. And so this is the example on one MSOA. Of course, for London, we have 983, and that's kind of our system of interest is London. So the next step of the routing part was to test some tools that are out there. We didn't really want to go for setting up servers or whatever. We thought it could be done with a more simple, straightforward approach. So we tested all the packages, mainly in R, I must say. I'm curious to hear about Python solutions to that because I'm more of an R user. And so we end up finding this CPG routing package that we put in very fast routing. It's definitely very, very useful actually, and highly recommend. And so yeah, we benchmark them for various types of mathematic sites, basically set up for this one. And the final step, of course, is a spatial interaction model, which we construct using, on the one hand, flow data from the sensors. We use 2011 data for the flows only keeping devices in the food tolerance, and we combine the two into an active travel node, kind of additional node. On the actual sort of implementation side, the equation that we use is the doubly constrained gravity model, it's also called sometimes. So we have some terms, A and O related to the origin, B and D related to the destination, and theta is the distance related to the exponent. I guess everyone who does geography is a bit familiar with that. And so in the end, the final step of our analysis lacked the proper tools to be done. So we ended up developing our own package that basically a bunch of functions. Doesn't do too many things, but it does them very quickly and efficiently. It's an R and C++ combined package using RCPP and RCPP Armadillo, the linear algebra library, open source linear algebra library. And in the end, the model sort of goes down to these three lines of code where we have a flow matrix, we have distance matrices from this previous step that I showed you, and a beta that we're trying to calibrate, which is the equation there. And if we test for various values, we obtain this kind of plots where we see that, for example, for walking, it's quite sort of distributed into qualities, and we notice that the commuting centroids actually give significantly better results. So it validates our approach to differentiating and looking a bit more closely at what are we routing. The cycling is a bit more smooth in terms of distribution of qualities of fit, but the quality of fit is a bit lower generally. And if we combine the two modes and look at the model quality here, it sort of gets the best of both worlds. It's does pretty well on all the types of networks. Finished, sorry. And at the same time, we have high qualities of fit. So yeah, there's a paper that covers a bit more than that. I was talking more on the software side, so the paper is on the left, and the package on GitHub, maybe soon on CRAN as well, on the right. Thank you for your attention.
Okay, so last talk before lunch is James.
It's me.
It's you. And I got your slides up first time. Gosh, that's really good. Don't be stressed that we're running 5 minutes late.
Yeah, I was going to try and speed run.
No, don't try and speed run it. We can have 55 minutes of lunch instead of 60 minutes of lunch.
Okay, great. Thanks, Stephen, for hosting the event, and Geovation for having us. My first spot for GUK. I've been to the global event a couple of times, but yeah, excited to be here. I think before I start the slides I've presented, I just wanted to make a few comments on what I've heard today. First of all, to Mike, I definitely don't know what OGR stands for. One of my favorite tidbits in geospatial software is that Fiona is the Python wrapper to OGR that's named after Shrek. As well as a public reference, I showed this at FOSCG in Florence last year, and I think it's basically I read this, and it's Paul Ramsey, who is the founder of, he created PostGIS, and now he's his own company that just hosted databases. And I'm not going to talk about the architecture that we use in my company today, because hopefully it's boring enough to not be remarkable. And actually, that being said, it's very, very similar to what I presented. Not saying that is boring, but it's a good solution. But I think what I'm trying to focus on today is more how we bring our product to market and the value that we hope to bring with it. And then I thought some of Helen's points were very valid in that I'm trying to de-jargonify my life. So I try to, when I refer to the cloud, I just say someone else's computer. And actually, an interesting thing that happened in my time in my organization is that we were advertising for a GIS role. What ended up happening is that we had hundreds of applications, like Esri acolytes, who knew how to use ArcGIS, but no one knew very much about cloud engineering or software development. So we ended up just tilting it towards geospatial engineering, and that's kind of basically the default JD that goes out. My company, it's called Satellite View. So Satellite View, we're a thermal remote sensing company, so a satellite imagery company. And so the company offers kind of first of its kind, a medium of remote sensing. So we're in the infrared from red, the medium wave infrared from red. So for those of you who know about remote sensing in the room, it's 3.5 to 5 microns. And here is a satellite view medium wave infrared imager. We're called a HotSat. So this is the first of a planned 8 HotSats that'll go up on board Transport Array, which is a SpaceX mission launched in June. There was 75 satellites on board this mission. It was just great, because there was a live stream, everyone was on Slack, kind of sharing kind of hopes and dreams, and thankfully it got up okay. And so, yeah, something to know about our satellite is that it's built by a company called SSTL, who are in build for series satellites, and it's quite agile, so you can point quite far off mid-air and to basically acquire points at a given target, or target rather, point left target. And so as I said, there's 8 planned. Currently, the satellite's undergoing commissioning, but we have proof that I can produce imagery. And if you're lucky enough, I will shove it in your face later and ask you your opinions. And so to date, I've been with the company for nearly 2.5 years. And what we've been doing is flying 2 different sensors, medium wave sensors. One was kind of using the sensor that's on board the satellite with the optics a little differently set up, collect some data, prove out use cases. And since that was taken back, we went and bought a second medium wave imager. It's very similar performance-wise to what's on board the satellite. But ultimately, we ran this kind of early access program to get people's ideas of what use cases could be. And so we're going to give you a bit of an insight there, as well as talk through some of the processing pipeline. So yeah, just on the aerial data, I mentioned we flew a prototype of the satellite on board a plane. And a lot of the kind of nitty-gritty detail of what goes in kind of image processing pipeline, I'm not going to touch on. I'm just going to say that there's a lot of complexity from the top right there. We have kind of raw readings from the sensor, and to do basically some operations, non-uniformity corrections, one flat fielding to produce the image on the bottom right, which is kind of visually uniform, and if not like there's more steps towards calibration, which I'm not going to talk about. I'm asking about if you're really curious. One other thing to notice that it's a video camera, so for every time we acquire a target, we collect 25 frames over the course of a second. Kind of builds redundancy as well as like potentially some applications, though we're still feeling that out. So curious to hear what your thoughts are there. And so ultimately, the reason I wanted to present is that for me, I kind of lead the image processing team. Our company wouldn't be possible without Phosphor-G. In fact, we're completely dependent on it. And one thing that we've kind of built out is this kind of georeferencing pipeline. So we thought about going to a vendor for this solution in the first instance. And in a lot of cases, you'll have accurate enough onboard kind of GPS on your plane to be able to like directly georeference it. We didn't have it at the time, so we just kind of built in kind of processing pipeline, which basically does the georeferencing. And to Helen's point as well on kind of the basics of GIS, like reprojection, coordinate systems, geodesy, it's things that are actually like the nuts and bolts of this. But it's very difficult to find experts in those sections. Like I was lucky enough to do a PhD in photogrammetry, so I feel like confident enough to bring that, but kind of making sure that we know exactly what's going on. And it's kind of like this kind of ML black body problem isn't good enough for me at least as a data producer. But anyway, we do use ML. And in fact, this is kind of a standard georeferencing pipeline. You're probably, some of you relatively familiar with this. You take an image up here on the top left, and you run some algorithms to detect points of interest. So these are like type points, traditionally known as. And there's like a family of algorithms called feature detectors, which you can run on this. And we kind of need to sense the features on a reference data source as well. In this case, we use Sentinel-2 as a kind of global base map. We kind of just snap to grid. That was the kind of solution that we developed and showed pretty good performance. And so just some of the software packages used in that pipeline, we use Raster.io. I think anyone who's used Earth observation data and is a Python programmer is probably pretty familiar with it. ODC Stack, for those of you who don't know, I know Ali mentioned Stack as well. We use it heavily as well as produce into it. ODC Stack is basically like, you can query a metadata store. Mike was talking about the virtue of correct metadata. But ultimately, you can query a metadata store for, say, for example, give me cloud-free images of this area the last 2 years. You can also go and get the data then without doing anything extra, so it's very useful. And then cloud native, all that kind of stuff. So yeah, just we kind of did some validation work internally on this using the aerial data collection. So we flew 100 flights in various parts of North America and Europe. And then we did a little bit of software development to kind of simulate how we think the satellite imagery would look like, the aerial data, including often viewpointing as best we could, but it's very tricky to do that correctly. So we made some compromises. So yeah, you can see an example of what we think the satellite imagery would look like. We include some sort of guesses to the atmospheric effect, as well as kind of something called the point spread function, which describes how accurate your sensor is at picking up edges. We produce some metrics that we hope to publish and hope to validate actually with the satellite imagery. So thanks Phosphor-G for making all that possible, basically. And as well as this, we're like heavily tracking Stack, and we're huge users of it. And I think it's basically the best thing since sliced bread when it comes to describing Earth observation imagery. And so I was such an advocate, and I was kind of the first engineer in the door. I was like, we have to put something out there immediately. So thankfully, I was allowed to release Stack.solid.com. It's five imagery samples from the aerial imagery that was collected was over 2 years ago now around Liverpool. It's some interesting stuff to look at because I kind of wanted to take some of the community down with us on the journey. I can talk about that a bit more afterwards. But just to give you an overview of some of the use cases that we're looking at and some of the imagery that we've collected. We see some market fit potential in industrial activity monitoring, seeing which sub-parts of plants reacted, things like that. In the top right, we flew over a wildfire which was just outside Berlin, if you remember last year. We could kind of detect the fire fronts at greater precision than anyone on the market at the minute. And in the bottom right, you can kind of see an outflow from a power plant. That's a Liverpool Stano refinery. Potentially some monitoring as temperatures there. This is my favorite one because apologies for the color bar going all over the place. It's just I dug up some of these from the archive. This is a glass blowing facility where glass is manufactured. And this is a warehouse. And you can just see that obviously glass blowing you light up at very high temperatures, but it's kind of the ultimate proof of life that it's doing something correctly. This is the satellite piece of it. And again, show you some satellite imagery. And just the last note that we actually, I in conjunction with SparkGeo, we're a geospatial consultancy, the UK branch, we organised a stack-themed meetup. And as Mike was saying, meetups to do with metadata I thought would be very difficult to get people interested. But we had roughly 40 people come to the Staffy offices, which were just in central London down at County Hall. And it was a great success. We hope to run another one in January, February. It's our kind of way, while we're not actively contributing to the software side, we're kind of looking to do some community building, particularly around London and the Greater South East. And so please do come along. We're not advertised. So that's me. Thanks very much.
Brilliant, thank you. So thank you to those three lightnings. Well done, because you're kept just about to time. Lunch is over there, right? But before you eat lunch, there is one box platter, I don't know how they're going to be served up, which says vegan. Let the vegan eat the vegan stuff before the rest of you eat the vegan stuff. There's plenty of vegetarian and non-vegetarian. If the vegan stuff is there in 15 minutes, then you can go for it. Second thing, look, there's still only 2 post-it notes here. Okay, good for you, Yogesh. There's just about to be 3 post-it notes. I need 5. I need more than 5. Right, lunch, drinks, conversation, 55 minutes. We restart at 1:45.
If you're really